Hey guys, I'm going to show you something pretty cool about scientific notation. Let's say 3.4 times 10 to the 5th. Let's say, for some reason, I want to make this 10 to the 6th. If I make this number 10 smaller, I can make this number bigger. What does that mean? 3.4 times 10 to the 5th equals, I'm moving this over, 0.34 times 10 to the 6th. Do you see how I did that? All I did was move the decimal over once to the left, and this number went up. Now watch this. 3.4 times 10 to the 5th. Let's say I want to make this number smaller. All I do is move this number over. It can equal 34 times 10 to the 4th. It works just like that. So there's some really complicated math rules about how that works, and I could teach you those rules, but I don't think you really care, and it's not the most important thing ever. You'll figure out later on in math, in future years. It'll make more and more sense to you. For now, you just need to know the basic rules. I don't know why I keep doing threes, but let's say 8. If I make this number smaller, then this number gets bigger. And if I move the decimal over this way, this number gets smaller. So 0.38 times 10 to the 9th. These are equal to each other. I could do it again. I could move it this way. 0.038 times 10 to the 10th. I could do it again. 0.0038 times 1011. That's all you have to do. Let me show you again. So 4.8 times 10 to the 4th. I want to make this 4 right here. I want to make it a 5. So I have to move this decimal over and make it smaller. So 0.48 times 10 to the 5th. All I did was move this decimal over here. 7.7 times 10 cubed. I want to make this 3 a 4. So all I do is move this decimal back, and I move this up. 0.77 times 10 to the 4th. It's all you have to do. It's that simple. We're making it bigger the whole time. Let's do a couple more where we make it smaller. 3.9 times 10 to the 5th. I want to make this number a 4. So as this goes up, this goes down. So I move this over here, make that 39 times 10 to the 4th. 6.8 times 10 to the 9th. As this number gets bigger, this number gets smaller. So that, I move the decimal over 1. I've got 68 times 10 to the 8th. Now, Mrs. Gibbons, why in the world did you teach me any of that? Because I'm about to teach you something wacky. 4.8 times 10 to the 5th plus 6.2 times 10 to the 5th. I need to add this plus this. Now we're lucky here, the exponent is the same. If the exponent's the same, all you have to do is add these two numbers. 4.8 plus 6.2 . 11. So this is 11 times 10 to the 5th. Let's do another one. I don't know, 9.7 times 10 cubed plus 2.2 times 10 cubed. They're the same, exponent's the same. So all I have to do is add these. 9.7 plus 2.2 is 9, bring down my decimal, 11. 11.9 times 10 cubed. Simple, right? Simple. Wait for the next step. We're going to do different exponents. 6.1 times 10 to the 4th plus 3.2 times 10 to the 5th. Oh, Mrs. Gibbons, how do we do this? Well, if you remember, when we're adding exponents, the bases can be different, but the exponent has to be the same. The exponent has to be the same. It has to be 3 to the 5th plus 8 to the 5th. That equals 11 to the 5th, right? Okay, let me just erase that. So we have to do something to make these two exponents the same. Well, let's do the lesson that I just taught you. Let's make this number smaller and this number bigger. We move this decimal over here. So we've got 0.61 times 10 to the 5th plus 3.2 times 10 to the 5th. Look at that. Now we can do 3.2 plus 0.61183. This equals 3.81 times 10 to the 5th. That wasn't really so hard, right? Let's do another one. 2.5 times 10 to the 6th plus 3.2 times 10 to the 7th. What do we do? What do we do? You know what? Let's make this one smaller. So as this one goes up, this one goes down. So 2.5 times 10 to the 6th. I move the decimal over once. I've got 32 times 10 to the 6th. Now look, my exponents are the same. All I have to do is 32 plus 2.5 is 5, 4, 3. I've got 34.5 times 10 to the 6th. Let's do one more. 3.8 times 10 to the 3rd plus 2.6 times 10 to the 4th. Now it's your choice if you want to make this one bigger or this one smaller. It doesn't matter. I'm going to go with making this one bigger. So as this number goes down, this number goes up. To make a number smaller, you move the decimal to the left. So we've got 0.38 times 10 to the 4th plus 2.6 times 10 to the 4th. All we do is add these two numbers, 2.6 plus 0.38, 8, 9, 2, 2.98 times 10 to the 4th. All right, so I'm going to do one in subtraction. I'm just going to do one in subtraction to show you it works the exact same way. 9, let's just say 9 times 10 to the 7th minus 7 times 10 to the 6th. Let's make this one bigger. So as this number goes down, this number goes up. Decimal's here, so it has to come over and be here. So 9 times 10 to the 7th minus 0.7 times 10 to the 7th. Now we can do the same thing. 9 minus 0.7. 9 minus 9.0 minus 0.7 is 8.3. 8.3 times 10 to the 7th. This is absolutely the most difficult thing that we've done so far in class. I want you to be honest with me. If you don't understand it, just tell me. If you personally are just too embarrassed to admit it in front of the class that you don't understand, reach out to me on Teams. You and I can have a personal appointment. But it's easy. Just remember, as this number goes up, this number goes down. As this number goes down, this number goes up. And when you're adding and subtracting, these have to be the same. All righty.